I'm going to talk about today. Before we get actually into the very technical details and project-based context, well, we probably have all heard there's a fancy technology actually just came out of the market early this year called ChatGPT. And I have actually used it. I'm not too sure whether you guys have ever used it. I use it in quite a lot of different situations and circumstances. For example, I asked it to write me an email to Jennifer and whether I can give a seminar talk at her research center. And you're more than welcome actually to spend some time actually read it. And ask it, and could you please let me know if you were Jennifer and getting this email, would you take it as a spam? And is there any reason behind it? So my perception of what ChatGPT and many of those AI technologies, particularly those language models, can do is that they're very good at giving some general and accurate answers to those questions that have not too much boundaries or context information behind it. So a typical example that I am going to show is called Orange. This is supposed to be a video call. So Orange is a very simple word, but really it depends on the context. It can be interpreted by many different scenarios. So it can be, for example, a color, a fruit, a telecom company, or perhaps even a surname. So that's the kind of limitation that most of those language models at this moment still have some problems with. That is inferring the hidden context information. And the same example actually also exists in the construction scheduling. So this is a typical schedule I actually took from the a construction project. So you probably can see that there are like 3 stages of constructing a foundation at different areas. One of them is called base 3, the other one is called base 4. Probably this other one I just popped it off, but perhaps it's another name for another base. But literally you can see that all the tasks it's going to do are exactly the same. All starts from excavation, shuttering, pouring concrete, backfill, and then job done. But then when you look into details, they are slightly different. For example, this one, the one that I kind of currently circled it out. So it kind of framed the shutter and boat sets into a different way and a few different tasks into it. Means that it actually breaks down into more details. For example, including the blind and reinforcement, placement, and etc. So that is kind of the challenge that we have in those kind of unstandardized or semi-standardized data, particularly those that we don't really have to ask people to fill the form. That's the problem is called repeated activities are usually described in different levels of detail and lacks of consistency. Because of those unstandardized or semi-standardized data format, we have lots of problems actually to process these types of data. So just before we actually get into the details of the project, there's a little reflection of what AI really can do. It can give us some project data insight, for example, the safety hazard reporting, etc. It can also give us some of the forecasting on the project performances, how it's really going to look like in the next few years. And of course, one of the most powerful application is it probably can generate different texts and cheat in an exam. And I hope my student is not doing that. But I'm pretty sure some of them probably are trying to do so. But what AI can't really do yet, of course, the first thing is what we call experience-based tasks. And many construction projects evolves quite a significant amount of experience-based tasks. This is, for example, using the domain knowledge, assessing when this foundation can be done. This kind of experienced judgment cannot be done by either the language model or other fancy technologies yet. Another thing that, based on my experience, is that AI cannot do yet is inferring the omitted information from the context. Back again, the orange stories that we just described. So what we did in this project is our first objective, which is actually the most important objective, is to find the best practices from thousands of project schedules. And once this objective is achieved, we try to benchmark our project performances across different regions and different project types, and to find out whether we have done pretty good in certain projects or whether certain teams are doing better than other teams in the same country or in the same region. And so in that case, we hope that we can help those, particularly those contractors, to learn some risks and uncertainties from their past projects. And then in that case, they can avoid repeating the same mistakes in the future projects. I've got two slides. The next two slides literally is going to be about some key definitions that I will start introducing later on. So the first one is about activity sequences and project types. So I guess it's probably good if we are on the same ground about those key definitions. So an activity that we call in this project at this moment, we call it as an operation or process that consumes time or possibly other types of resources. So an activity at this moment, we typically take just one single line that has been put in the construction schedule as an activity. But of course, some other programmers may call it task or other thing else, but we prefer to call it activity throughout the whole project. And a sequence is usually a chain of activities that are happening in order to deliver the same thing. For example, the wall construction usually would have like at least two activities. The first one is that you erect the false work, and then probably you have to pour the concrete. And for example, in this example that we just show, the basement construction would have like 1, 2, 3, 4, 5, 6 activities. That is one sequence, we call that. So because these 6 activities are exactly on the same chain. And the last one is a project type. We call a project type as a kind of category of project for the same functions. For example, road, highway, infrastructure, and others. After that, we used two statistical not quite statistical, but two metrics to actually compare the time efficiencies between activities, sequence, and projects. sorry. Yeah. The first one is that we call this relative duration. Relative duration literally is a ratio of an activity or a sequence duration to the project duration. So the purpose of doing so is that is the variety of project size. For example, the time that we need to deliver a shallow foundation for a residential building would be significantly different from a deep foundation of a skyscraper. So in that case, we don't really want to compare the duration of these two foundations directly, just in case. Because if we actually do so, it's quite unfair to say that the construction of shallow foundation is much more efficient than the construction of deep foundation. So we use this relative duration to compare the kind of the time efficiencies of different activity, project sequences, and projects. And since we have relative durations, of course, if some tasks or some sequences has been delayed, we also need to measure its deviation. So we have another metrics called relative duration deviation that we use to measure how long the actual duration of an activity or sequence will deviate from the planned duration. So if this number is closer to 1, means that the sequence or the activity actually is around the same time to be delivered with the planned time. If the time is kind of, if the RDD is equals to 1, means the required time is doubled. Now we come to the data we actually use. I have used about slightly over 5,000 of project schedules in total, and they were collected from one of the tier 1 company. So most of them, 30% of those projects are infrastructure projects, including the roads and highways. Of course, we have also some other projects like heavy construction projects. So heavy construction projects is different from infrastructure because it's more in water plant treatment, wastewater treatment, something like that. Some others are like industrial, commercial, and residential buildings, or some kind of transportation like car park, etc. But most of them are infrastructure projects. And then we kind of use the benchmark matrix to compare the performances of certain activities, sequences, and project types at different granularity levels. So this is the kind of metrics that we used. I am not really going into too much details of it because it's a little bit kind of difficult to interpret. So what I'm going to do is that I'll emphasize this the 3 blocks on a diagonal. So this is more like we kind of compare the same types of activities against each other in different projects in different sequences, see how it performs. And we have done this few, and the 3 down here, we have done that, but we didn't compare the findings with other blocks yet. Yes, I'll jump through this slide because I'm probably not going to get into details with these 3 blocks today. So the methodology that we use to kind of find the sequences, that's the kind of the most challenging part in this project, because as we said, there are lots of repeated activities that are written in in very different ways and at different level of detail. So the technical part we use is called graphical network. Similarly, I won't touch too many technical details today. And if you have any questions about those kind of fancy graphical neural network models, you're more than welcome to contact me later on about those details. But here today about this slides is a brief introduction about how it works. So graph network initially was kind of developed by Keep back in 2017. So there are two kind of key concepts in the graph, which is called node and edges. Node are those little small dots that you can see. And edges are those lines that connecting those edges. If we apply the same kind of graph concept into construction schedules, we probably can see that, again, the graph network, each color will they will do a classification, and then you can tell that which nodes belong to the same type of class. This is the whole purpose that we do for the graph neural network. We kind of do a classification and ask the machines or computers which nodes or which activities belong to the same class, or they probably look similar. So if we apply the graph concept into a construction schedule, this is what we are going to see. As we said, there are two concepts in a graph, node and edges. There are similarly two concepts in a schedule graph. So if we take each node as an activity and take each connecting edges as the logic link between those activities, we probably can map out our schedule like this. And you will see that you actually can see that very often in those kind of network analysis. So this is the way we actually do it. We kind of take all these activities as a node, and we consider the kind of logic link between activities as the edges that connecting those activities, as well as the lag between these two activities. Whether, for example, the activity B2 will start immediately after this activity A2 finishes. And then similarly, the graph neural network can do a little classification for us. For example, it probably will tell us whether that's A2 is a wall or a slab. If our model eventually gives us this kind of results, we then connect A2, B2, and C2 all together because first thing is that they are on the same chain, and second thing is that they belongs to the same class, means that they are serving for the same function called wall construction. So that's our process to get all those sequences from the scattered schedule data. And once we got that, we can do lots of things on it. For example, some of the statistics. And this goes to our findings. Overall, we found about 236 frequent sequences among those 5,000 projects. And 90 of them are on-site activities. The rest of them are more like, for example, risk assessment, design review, procurement processes, and some of them are prefabrications as well. And 36% of those on-site activities are 36 of those on-site sequences are those what I call RFC related process. RFC is a very typical word used by those those contractors. It's very simple, called rebar, formwork, and concrete. So even though one single acronym stands for almost 3 activities, but they use it very often in the schedule. So 36% of those on-site sequences are kind of what I call RFC sequences, but those RFC sequences can appear in different areas. For example, 37% of them are in wall construction, 34% are in the basement or foundation construction. Of course, there are also others like back bridges, like these are only probably seen in those bridge projects, columns, pit, approach walls, plinths, and slabs. And then once we got those kind of sequences, we also try to plot it across different projects types to see what kind of sequences are more often in, for example, building construction, infrastructure construction, and others. So this is the one that we actually can see. That we see that we actually found more super construction processes rather than the sub-constructions. So super constructions are, for example, frame installation, roof cladding, wall cladding, scaffolding, and temporary works. But substructure constructions are like drainage, earthwork, and road services. So my conclusion for that is that this one is the other way around, is that actually superstructure construction are more standardized by substructure construction. I don't really know why, but it seems like the superstructure construction is stored in a or written in a better way than the substructure construction. And we also try to plot it against the kind of benchmark matrix. And we had 2 major findings. And the first one is that we found the construction delay actually grows gradually over the granularity levels, from activity levels with almost no reported delays. This is the graph that you can see. We plotted the x-axis are those different types of activities. The y-axis is the relative activity duration deviation. So we use a box plot to do the plotting. And you can actually really see, except the partition, almost all other types of activities, there's no reported delays at activity levels. The story is a little different at sequences level. Cladding and drainage, very few delays. And earthwork, quite a lot. I probably understand why usually those earthwork would have quite a lot of uncertain ground situation or uncertain weathers. So earthwork has quite a lot of delays. And then RFCs. So here, this RFC, I didn't separate RFC superstructure and substructure yet. So I can't conclude whether it is because of the earthwork delay or other reasons. I literally can see that in terms of sequences, there are more frequent delays. But let's have a look. Let's have a guess. What is actually going to happen at project levels? At project levels, we're seeing lots of interesting graphs. So again, the x-axis are different types of projects: building, commercial, heavy construction, industrial, and infrastructure. And the y-axis are the project duration deviation. Almost all types of project has been report delay. No single project has, or a single type of project has got this 0 delays. And the median bar is also far more higher than the sequence level delay. So this is quite interesting, and we try to look back, see why this actually is happening. So the first reason we think is that there's a lack of progress updates. Some activities, they may finish in just 1 week or probably a few days. And those type of activities probably hasn't really been reflected in the schedule. So that's one of the reasons. And the second reason is that we believe there's probably long time lag between activities and sequences. For example, we suspected that perhaps the basement finished and then the site has been quite available and nobody actually is working on it for a while until the next task gets started. And the second finding is also a little bit interesting, is that because we have some prefabricated projects in our schedule as well. So we did a little statistics on it, and we found that prefabrication can reduce project duration and the likelihood of delay. Prefabrication can reduce project schedule, can reduce project duration, but if we use some of the statistics, it's not really that significant. So this figure A here is showing, it's just showing a box plot of different types of projects over the project duration. And we can only kind of visually see that there are not many differences in terms of those prefabricated projects and non-prefabricated projects. And probably some of those prefabrication projects has a shorter project duration, but we're not very sure yet. But in terms of project duration deviation, that is what we call project delay, there are some differences, but still we are not that sure. So that's why we kind of used a simple statistics. I think I used KW test or something else. Yeah. And our null hypothesis is that prefabricated projects have the same duration or the same duration deviation with non-prefabricated projects. And we did a project and we did the testing. And all the p-values are greater than 0.05, means that our null hypothesis is actually accepted, that there is no statistical differences. So later on, we tried to reach out a module construction in Australia and ask for their insight and feedback. What really is the reason actually behind it? So the feedback we got at the moment is that in terms of the time and cost, in terms of the time and cost, there are really not too many differences from the traditional construction. It's just the prefabricated education institutions are much more flexible to be disassembled and reused for other purposes. So, but this is only based on the feedback we got from a module construction company in Australia. We haven't investigated this further. And by moving forward, so to summarize a bit, there's a few lessons we actually learned from our past projects, is that there are lots of project characters and uncertainties. It is usually difficult to use statistics to assess different projects. For example, the prefabrication. Some projects, for example, I can't really say the name, but some projects, due to the construction constraints, perhaps prefabrication is the only solution for them. But it's like we can't really generalize saying that prefabrication is much better than the traditional construction. And the second lesson we learned is that there's a lack of updates and diluted data, because at the moment, our construction data are really coming from different sources. Some of them are even duplicated. I'll take the Hinkley Point C project schedule as an example. I've got really 400 project schedule of Hinkley Point C, which is a little bit surprised. And many of them are duplicated, and some of them probably summarized of the project schedule at one phase, and another one summarized the schedule at another phase, and there's no kind of just a one single schedule showed me the whole construction progress of that project. So there were like quite a lot of manual work to put these up. The third thing is about the kind of unreasonable resource allocation in the construction schedule. We have seen that some of the infrastructure constructions, because of some tasks, has been delayed. So the project managers kind of just put thousands of machine hours on just one single activities to get it delivered. So we think that there's probably a way that we can use the previous data to optimize or to avoid seeing this kind of situation happen in the future projects. And further into the future, we hope that we can have a data-driven dynamic project delivery approach that can help us predict and minimize the risk of delay and cost overrun, as well as safety. So in that case, when the construction actually is going on site, our project managers or construction managers can also be noticed by what really is going to happen in the next few weeks, and whether our current conditions is able to meet that requirement in the future. And yes, and then at the end, it's the acknowledgement for the traditional owners and custodian of the land where part of this research has been done. And if there are any questions, particularly those technical ones, please, you're more than welcome to contact me.